Hey, so we're going to do an absolute value equation, and it's pretty straightforward, but let's just solve this. So we have two possible solutions here. So I'm going to say, well, this could be positive, so let's do x minus 3 could equal 7, which is the same as x equals 10. And now I can check this. So I put this back in, so I'd say absolute value of 10 minus 3 equals 7. And that's just the absolute value of 7 equals 7, which we do know is true. Now, we could do another one. So I'm going to say, well, what happens if I chose the negative version of this? So now I have negative x plus 3 equals 7. And that's just the same. By rearranging, I subtract an x, or add an x to both sides and subtract 7. I get x equals negative 4. And then we'd substitute that back in and check it. Negative 4 minus 3 equals 7. So the absolute value of negative 7 equals 7. And we know that's true as well. So we've kind of gone through and shown that this has two possible solutions here. So we know that x equals 10 and x equals negative 4 are possible solutions. Now if we just graph this quick, so if we just went like this, now when x equals 3, I know that that's where my graph will bounce. When x is 0, y is 3. Okay, that was not a very straight line, but that's fine. And now, what this kind of shows me is that when x is negative 4, graph is 7, and that's probably right here, and this is about 10. So this point 10, 7, and this one minus 4, 7 correspond to this intersection line. And this line is y equals 7. So it's kind of like if we had this, we said the absolute value of x minus 3 equals y, and y also equaled 7. So I have this line, y equals 7, and then I also have this graph, which is the absolute value of x minus 3. So we've kind of just gone through and solved that.